Hello, this is question 8 on your paper 1 from AQA to November 2021. It's a trigonometric equations question. So we have to show that this equation is equivalent to this one. Yeah, so we have to work with this equation until we have an equation like this. We have only cos, which means we are going to try to eliminate this sine and tan. So the first thing I would do is to write tan as sine divided by cos and see what can we cancel. So we will have 3 sine theta, and instead of tan I'm going to write sine theta divided by cos theta. It's going to be 5 cos theta minus 2. I multiply everything by theta to get rid out of the denominator, and these two sine times sine will be sine squared, so I have 3 sine squared theta is going to be 5 cos squared theta minus 2 cos theta, just multiplying by cos. And now we have cos squared, and I can change that into cos squared. So I can write 1 minus cos squared, that I know is sine squared. It's going to be 5 cos squared theta minus 2 cos theta. I'm going to expand the bracket, so 3 minus 3 cos squared theta is 5 cos squared theta minus 2 cos theta. And I'm going to simplify and put terms together. So I'm going to put together the cos squared, and I will have 8 cos squared theta minus 2 cos theta minus 3, right? Equals 0. You have something and something squared, which means we can work with this equation as a quadratic. It's like having something like 8x squared minus 2x minus 3, if you prefer to solve it that way. Yeah. So when we factorize, we are going to have 4 cos theta minus 3 and 2 cos theta plus 1, just factorizing. Yeah, so if you prefer, you can factorize with x and then think that x is cos theta, if that is easier. Yeah, but that's what we have to do. So that's the first part. Then they solve this equation. This equation is the same that we have here, and they don't say hence like in many questions, but even if they don't say so, I would say it's probably easier to solve it this way. Yeah, because if this product is 0, that means each of the factors can be 0, and that's what we are going to do. This factor equals 0, this factor equals 0. So solving this equation is the same as solving this equation. So first factor is 4 cos theta minus 3 equals 0, and the second factor is 2 cos theta plus 1 equals 0. And we are going to solve, I don't know if I have space. Yeah, I'm going to solve both of them. Yeah, they are going to give me different solutions. Yeah. So in the first case, that means that cos theta is 3/4. You do cos minus 1 with the calculator, and you get that theta is going to be 41.4 degrees. 41.4 degrees to 1 decimal place, yeah, or 3 significant figures. I have the interval minus 180, 180. So I'm going to see if I have more solutions. If you remember, we can do this using the circle. It's really up to you. You can use the cast diagram, but I would use the circle. So we know the 41 degrees is somewhere here. So this is 41 degrees, and I need another angle that has the same cos. And cos, remember, is the x. Yeah. So the other angle is going to be this one here. That could be, so this one here. But so it could be this one, so the whole way, which is 360 minus 41.4, or if I had to write in this interval, it's going to be the negative version, so minus 41.4. Yeah, so my other solution is minus 41.4. Same with the other one. I'm going to say that cos theta is minus 1/2. If we do that with the calculator, theta is going to be 120. 120 degrees is here, so I can show you. 120 degrees is somewhere here, and we need the same cos. Cos is this one, so we are talking about this symmetrical angle in the x-axis, and again, we need the negative version instead of the positive one. So it's going to be, if this is 120, this is minus 120. Yeah, so these are my 4 solutions in my interval. Yeah. Next thing, hence deduce all the solutions of this equation. So if you compare this equation with the one before, it's the same equation, but I have, instead of theta, 1/2 of theta. So when we have a number multiplying the angle, the first thing you have to do, remember, is to change the interval. So we are going to write the interval for half theta, which means I'm going to divide everything by 2. So my interval is going to be this one, theta divided by 2, and 90, because it's going to help us to choose the solutions. And then I have the solutions for theta. Yeah, and now theta, which are these 4 solutions, now theta is really 1/2 of theta. So I can say that 1/2 of theta is 41.4 minus 41.4, 120, and minus 120. Yeah, because this was theta and now is 1/2 of theta. And I can just double these angles to have theta. So theta would be just double that, which is 82.8 minus 82.8, 240, and minus 240. Sorry, I should have get rid out of the angles first. These ones, these 2, are out of my interval. Yeah, because my interval is between minus 90 and 90. So these angles are correct. These 2 are out of the interval. So my only 2 solutions are these 2. And be careful, because in the other questions didn't say, but here we have to run to the nearest degree. Be careful with those things. So my answers are going to be 83 degrees and minus 83 degrees. Yeah, be careful with those rounding things so you don't get lose marks. Yeah, and that's all with this exam question.